derivative, now I know that the denominator can't go to 0, but my original function wasn't defined at 0 either. So on the domain in question, we only need to look at the numerator and set this to 0, which we're trying to find x sine x plus cosine x. Where does that go to 0? I'll do a little bit of manipulation algebraically here. And again, I've got this nasty scratch here on the bottom. So let me get rid of that. Okay, I'm going to scroll, and so again we're setting x sine x plus cosine x equal to 0. So I'll push over the cosine x. And how about divide by cosine x? And then divide by x. So sine x over cosine x is the tangent function. So this will go to 0 precisely when the tangent function is equal to minus 1 over x. Now that doesn't have a very nice algebraic technique to solve this. In fact, you can't really do this in closed form. Now we could use a process called Newton's method, or Taylor series expansion, but we haven't got that far in our calculus toolbox. So what I'm going to do here is do a little bit of estimation here, and tangent x equals negative 1 over x when the two graphs intersect. So I know what the tangent function looks like. I'm going to quickly draw a sketch of that. And I'll put a tick mark here, tick mark there, and I'll put my vertical asymptotes here. And if I draw this quick, maybe I can be more accurate because I'm not a very good sketcher by pressure. Okay. And if I do this again, all right. So over here, this is 5 pi halves. This is pi halves. Right there is 2 pi. Let's see here. Oops. Here we go. That's pi. This is 3 halves pi. So I'm getting a little bit ahead of myself here. Draw another one out here. This is 5 pi halves here. This is 2 pi. Whoa. And, okay. Does not like me here. Okay. Well, that's a horrible tangent function, but again, tangent function's periodic. Its period is pi units, and here it's at 0 at 0, pi, 2 pi. Now I'm going to draw the 1 over x function, and it's going to look something like what that's close to 1, and it's going to look like this. Now, I lied a little bit. This isn't the 1 over x, it's the negative 1 over x. And I'm going to highlight some things. There's the intersection there, and there's the intersection there. So when we look at this, tangent x will equal minus 1 over x when the two graphs cross. So that's here at this intersection point here and intersection point here. So it's very close to pi. Of course, it's not at pi because 1 over pi is not the same thing as 0. And over here, it's not at 2 pi because 0 is not the same thing as 1 over 2 pi. So the zeros of this equation x sine x plus cosine x are very close to pi and very close to 2 pi. just a little bit less than pi and a little bit less than 2 pi. Okay. Now there's also zeros on the left-hand side. I'm not going to draw those. By symmetry, they'll just be the opposite of what we have. So it's going to have zeros. It's going to have positive zeros. And these will be at, how about I say, near pi and 2 pi. You could be a little bit more accurate by pi minus some small delta and 2 pi minus some small delta. And it's going to have negative zeros. Near minus pi. So on the other hand, it will be minus pi, again, very close to minus pi, but not quite, plus a little delta, and 2 pi plus a little delta, so minus 2 pi. So we're going to have zeros very close to pi, minus 2 pi, and 2 pi. Those will be critical numbers. So if we look at the sketch, so on the right hand side, this is near x equal 2 pi minus some small positive number. This is near pi minus some small number. And over here, remember when I said the local maximum here, if I just switch the sign, will become a, local minimum will become a local maximum over here. So this is going to be near minus pi plus delta. And I literally changed the sign. The minus pi for pi and plus delta instead of minus delta. And over here on this side, this will be near minus 2 pi plus delta. So there we have it. We've got a local max near 2 pi, a local min near pi, another local max near minus pi, another local min near minus 2 pi, and there's a vertical asymptote at x equals 0. So while this is our sketch, let's go ahead and verify with technology. Of course, the homework problem said, you're not supposed to use a calculator, but heck with it. Let's hit graph. And as you can see, each of these tick marks is 1 unit. So there's the vertical asymptote that we had before. 1, 2, 3. So pi is 3.14-ish. And so notice there's a local minimum near pi. 1, 2, 3, 4, 5, 6. 2 pi is 6.28. There's a local maximum near 2 pi. And notice it's odd symmetry. So here was near pi for a local minimum. This is going to be near negative pi for a local maximum. Again, odd symmetry. This was near 2 pi for a local maximum. So near minus 2 pi for a local minimum. Of course, these are about, right? So near these pi values. And that completes problem 301.